Hi everyone, welcome to PharmaGrid. So today we are going to discuss 5 more calculations related to pharmacokinetics portion. Question number 16. It was determined that 95% of an oral 80 mg dose of verapamil was absorbed in a 70 kg test subject. However, because of extensive biotransformation during its first pass through the portal circulation, the bioavailability of verapamil was only 25%. Assuming a liver blood flow of 1500 ml per minute, the hepatic clearance of verapamil in this situation was. So in this question, we need to calculate the hepatic clearance. So the equation to calculate hepatic clearance is equal to Q into ER, where Q is the hepatic blood flow and ER is the extraction ratio. And the extraction ratio can be calculated using this equation, that is Ca minus Cv divided by Ca. Okay, Ca means it is the concentration of the drug in the blood entering the organ. And Cv is the concentration of drug in the blood leaving the organ. And the Ca and the Cv can be easily calculated or can be easily determined from this question in the question itself. Okay, so see the question once again. It was determined that 95% of an oral 80 mg dose of verapamil was absorbed. Okay, so here 95% of the 80 mg dose of verapamil get absorbed. This means 95 divided by 100. Okay, that is 0.95. And this 0.95 can be taken as the Ca value, okay, which is the concentration of the drug in the blood entering the organ. And what they have given, after this first pass metabolism, the bioavailability of verapamil was only 25%. Okay, so after the first pass metabolism, okay, the concentration of the drug in the blood leaving the organ, the CV value will be 25%. 25% means 25 divided by 100, that is equal to 0.25. So here the Ca value is 0.95, which is the concentration of the drug in the blood entering the organ, and 0.25, it is the concentration of drug in the blood leaving the organ. That is Ca minus Cv divided by Ca. We will get the value of extraction ratio as 0.7368, or otherwise we can calculate this extraction ratio in another method also. That is, first calculate the 95% of 80 mg dose. How we will calculate the 95%? That is 95 divided by 100 into 80. Okay, we will get the value as 76. Okay, so we got the value of Ca as 76, and also calculate the Cv value using this, that is 25 divided by 100 into 80. Okay, so we will get the value as 20. So substitute this. Okay, instead of these values, substitute the values what we have got by this equation. So anyway, we will get the final answer as 0.7368. Okay, which is the extraction ratio. Both of these methods are correct. So if we got this extraction ratio, next step is to calculate the hepatic clearance. Okay, hepatic clearance can be calculated by the equation Q into ER. Q is already given. What is Q? Q is the hepatic blood flow or the liver blood flow, which is given as 1500 ml per minute. Okay, so hepatic clearance is equal to 1500 into extraction ratio value, which is 0.7368. So we will get the answer as 1105.26, which is approximately equal to 1110 ml per minute. So here the correct answer is option D, which is the hepatic clearance of verapamil in this situation. Next question. A new cardiac glycoside has been developed for oral and intravenous administration. The drug has an elimination half-life of 24 hours and an apparent volume of distribution of 3 liter per kilogram. The effective drug concentration in plasma is 1.5 nanogram per ml. Toxic effects of the drug are observed at drug concentrations above 4 nanogram per ml. The drug is 75% bioavailable after an oral dose. Calculate an oral maintenance dose to be given once a day for a 65 kg male patient, age is about 68 years, with congestive heart failure and normal renal function. The aim is to achieve an average plasma concentration of 1.5 nanogram per ml. The dose should be. So in this question, we need to calculate the maintenance dose. Okay, so in our biopharmaceutics and pharmacokinetics related questions discussion, we have learned that this volume of distribution is useful in determining the loading dose, whereas this clearance is useful in determining the maintenance dose. Okay, so in this question, we need to first calculate the clearance. Okay, so what all are the data given here? apparent volume of distribution, that is VD, is given as 3 liter per kilogram and the patient weight is 65 kg. So volume of distribution VD is equal to 3 into 65, that is equal to 195 liter. Next step is to calculate the K value. K is the rate constant. That is the equation to calculate clearance is equal to K into VD, where K is elimination rate constant and VD is the volume of distribution. So how to calculate the value of K? That is 0.693 divided by T half. T half is the elimination half-life. So here the elimination half-life is 24 hours. Okay. So substitute the elimination half-life here. We will get the answer as 0.0288. So we got the values of both VD and K. Then substitute the values in the equation for clearance. So we will get the answer as 5.63 liter per hour. Okay, so the clearance value we got it as 5.63 liter per hour. Next step is, in the question they have given the plasma concentration, which is denoted as Cp. That is, the plasma drug concentration is 1.5 nanogram per ml. Okay, so here the plasma concentration is expressed in nanogram per ml. We need to convert it into milligram per liter. How to convert this nanogram into milligram? This 1.5 multiplied by 10 raised to minus 6. Okay, 10 raised to minus 6. And then it will be converted to milligram per ml, and we need to convert it again to milligram per liter. Okay, so again this value divided by 0.001. So we will get the value of Cp, or plasma drug concentration, as 0.0015 milligram per liter. Next step, we have got the all values. Next we can substitute what we have got in the maintenance dose equation. So maintenance dose in milligram per hour can be calculated by this equation, that is Cp. Cp is the plasma drug concentration in milligram per liter multiplied by clearance in liter per hour multiplied by the time interval divided by F. F is the bioavailability or bioavailable fraction. So here the drug is 75% bioavailable. So what will be the F value? 75 divided by 100, that is equal to 0.75. So substitute all these values in this equation. Okay, 0.0015. This is the plasma drug concentration value, and 5.63, which is the clearance value, into 24. 24 is the elimination half-life divided by 0.75, which is the F value. So we will get the answer as 0.270 milligram. So here the correct answer is option D. Question number 18. Cocaine has two ester bonds that hydrolyze to produce either benzoyl ecogonine or ecogonine methyl ester. At 40 degrees Celsius and pH 7.25, cocaine has a half-life of 5 hours. If the total extent of degradation is not allowed to be more than 10%, what would the shelf life be for cocaine under those conditions? So in this question, we need to calculate the shelf life for cocaine. So we can use two equations to calculate the shelf life. That is, first one is T90% is equal to 0.105 divided by K, or this T90% or shelf life can be calculated by one more equation, that is 0.152 into T half. Okay, so let's see the first method. So the equation to calculate T half or elimination half-life is equal to 0.693 divided by K, and this K value can be calculated from this equation. So K is equal to 0.693 divided by 5. Here the half-life is given as 5, so substitute 5 here. So we will get the value of K as 0.1386. Okay, next substitute this value in the equation for T90%, that is equal to 0.105 divided by 0.1386. So we will get the answer as 0.76 hours. Okay, now using the next method, next equation is T90% is equal to 0.152 into T half. Okay, 0.152 into T half is 5 hours. Okay, so we will get the same answer, that is 0.76 hours. So here the correct answer is option A. So either you can use both these equations in order to calculate the shelf life. Next one, lignocaine hydrochloride is available for intravenous injection as a 2% solution packed in 5 ml disposable syringes. The dose is 1 milligram per kilogram of body weight by slow intravenous injection. The volume of solution that should be used for a patient weighing 60 kilogram is. So what all are the data given in this question? Lignocaine hydrochloride is available as a 2% solution. So 2% solution means 2 gram is present in 100 ml. Okay. So let's calculate the amount take it as x. Okay, so let it be x gram present in 5 ml. Okay, because it is given that this 2% solution is packed in 5 ml disposable syringes. Okay, so let it be x gram present in 5 ml. Therefore, x is equal to, cross multiply these values, that is 2 into 5 divided by 100, that is equal to 0.1 gram. Convert this into milligram, we will get it as 100 milligram. Okay, so 100 milligram is present in 5 ml. Okay, so here dose is given as 1 milligram per kilogram of body weight, and the weight of the patient is 60 kilogram. So dose will be 1 into 60, that is equal to 60 milligram. Okay, 60 milligram. So from this step we got the value of, that is 100 milligram is present in 5 ml. Okay, 100 milligram is present in 5 ml. Now we need to calculate the volume that contains 60 milligram of the drug. Let it be y. Okay, let it be y. Therefore, y is equal to, cross multiply, 60 into 5 divided by 100, that is equal to 3 ml. Okay, so here the correct answer is 3 ml. Question number 20. The volume of distribution of drug C was determined to be 20 liter. What would be the expected plasma drug concentration immediately after an intravenous dose of 2 milligram is given to a 70 kilogram male patient? Okay, so here we need to calculate the plasma drug concentration. Okay, plasma drug concentration. So what all are the data given here? VD is equal to, that is volume of distribution, is equal to 20 liter, and dose is given as 2 milligram. Okay, dose is given as 2 milligram, and the weight of the patient is 70 kilogram. So the equation to calculate the volume of distribution, VD is equal to dose administered divided by initial plasma drug concentration, or it can be denoted as VD is equal to dose by CP. CP is the initial plasma drug concentration, and here we need to calculate the value of CP. VD we already know, which is 20 liter, and dose is equal to 2 milligram. Okay, so CP is equal to, or initial plasma drug concentration, is equal to 2 by 20. We will get it as 1 by 10 milligram per liter. Okay, and we know 1 milligram is equal to 1000 microgram, and 1 liter is equal to 10 deciliter. Okay, so see here the options are given in microgram per deciliter. So we need to convert our answer into microgram per deciliter. So we require these conversions. So convert this value, that is 1 by 10 milligram per liter, into microgram per deciliter. Okay, using these conversions, 1 into 1000 divided by 10 into 10. So we will get the answer as 10 microgram per deciliter. Okay, so here the expected plasma drug concentration is 10 microgram per deciliter. So here the correct answer is option D. So with this question, we have completed today's question or calculations discussion. Thank you everyone for your support, and please like, share and subscribe my channel. And if you have any doubts or comments, you can share your valuable posts or comments in the comment section. Thank you everyone. Thank you for watching this video. Have a good day.